Good day, class. This week, we will continue to learn about Newton's laws of motion. According to our schedule this week, you answer the anticipation reaction guide about the laws of motion and explored the forces and motion basics PhET simulation on Tuesday. Yesterday, you read and watched a video about the second law of motion, which we will discuss today. We will also use the forces and motion basics PhET simulation today to investigate the factors that affect the acceleration of a moving object. Finally, tomorrow you will answer the guided generalization based on another minute-to-win-it game. The approval of 2 games per group for the Newton's Olympics will be started tomorrow and will be due on September 25, 2020. Are there any questions, clarifications so far? Our learning targets for this week are the following. I can investigate the relationship between the amount of force applied and the mass of an object to the amount of change in the object's motion. I can generalize that Newton's laws of motion influences the design and implementation of Newton's Olympics. Before we proceed to the second law of motion, let us take a look at forces and motion PhET simulation and recap the law of inertia. In this simulation on the screen, will the crate change its state of motion? Yes. According to the law of inertia, objects at rest will remain at rest unless acted upon by an external net force. What about in this simulation? Will the crate continue to move when the man releases it? Yes. According to the law of inertia, objects in motion will remain in motion unless acted upon by an external net force. Since the simulation shows a frictionless interaction, then the crate will continue to move with the same velocity because of its inertia. What is inertia again? It is an object's natural tendency to resist changes in its state of motion. When there is already an external net force that is applied to a moving object, or object at rest, the object's state of motion will change according to another law of motion, the law of acceleration. Let's read the statement of the second law of motion, the law of acceleration. The acceleration of an object is directly proportional to the magnitude of the net force acting on it, and inversely proportional to its mass. According to the second law of motion, acceleration and net force are in direct proportion, which means that whatever net force changes, acceleration changes by the same factor. The symbol for directly proportionality is the Greek letter alpha. Hence, we can write their relationship as acceleration alpha net force in symbols A alpha F. In the forces and motion PhET simulation, we can clearly see how an object's acceleration changes according to the net force applied. Let's observe what happens to the acceleration of the crate pushed by the man as the amount of net force is increased. What do you think will happen to its acceleration when we double the net force applied to the 50-kilogram crate? How about when we triple the net force applied on the same object? Let's observe. With a 100 Newton net force applied to the 50-kilogram crate in this frictionless simulation, its acceleration is 2.00 meters per second squared. When the net force is doubled, the acceleration becomes doubled also, 4.00 meters per second squared from 2.00 meters per second squared. And when the net force is tripled, that is 300 newtons, its acceleration is also tripled, 6.00 meters per second. What do you think will happen if we change the mass of an object that is being pushed? Let's observe. When we change the mass by adding another object and apply the same amount of force, the acceleration changed. With 400 newtons applied to a 50 kilogram mass, its acceleration was 8.00 meters per second squared. But when we double the mass, making it 100 kilogram, the acceleration became 4.00 meters per second squared. It became 2 meters per second squared when the mass pushed was 200 kilograms. To summarize, we know that the acceleration of a moving object is directly proportional to the net force applied and is inversely proportional to the mass of the object. This means that the greater the net force applied, the greater is the acceleration, and the bigger the mass, the lesser the acceleration. From the second law of motion, we can derive the formula in finding net force. Net force equals mass times acceleration, or F equals m times a. Multiplying mass to acceleration, the units are kilogram times meter per second squared, which is equal to Newton. Thus, 1 Newton is required to accelerate a 1 kilogram mass at 1 meters per second squared. Applying the law of acceleration, please answer the table. If mass remains constant, doubling the force doubles the acceleration. If force remains constant, doubling the mass halves the acceleration. How can maximum acceleration be achieved? To maximize the forward acceleration, the designer makes the motorcycle as light as possible. That is, minimizes the mass and uses the most powerful engine possible, thus maximizing the forward force. May the force times acceleration be with you.